Welcome back to Refreshing Careers. Today's topic is time value of money, and we'll be doing the part 4 of it. In today's video, we'll be covering the future value. We'll be covering the future value of multiple cash flows. Multiple cash flows can be of two types. It could be either equal cash flows called as annuities, or it could be unequal cash flows. Now, what's the meaning of equal cash flows and what's the meaning of unequal cash flows? Let's say if in year 1 you're getting 500, year 2 you're getting 1000, year 3 you're getting 1500. This is a case of unequal cash flow. Okay, this is a case of unequal cash flow. In year 1 you got 500, year 2 you're getting 1000, year 3 you're getting 1500. Here what is happening? The amount is different. The amount received each year is different. And at the end of the year, you need to calculate what is the amount that you receive at the end of the year. That means you need to calculate the future value of the amount that you would be receiving at the end of the year if these are the cash flows and if these are unequal. The second case is that of equal cash flows or annuities. This is simple, just opposite of what we saw just now. If you're getting 1000 in year 1, if you're getting 1000 in year 2, you're getting 1000 in year 3. So what is happening here? The amount that you're getting at the end of each year is one and the same. If the amount that you receive at the end of each year is same, then this is called as equal cash flows, or it is called as annuity. This is called as equal cash flows, or it's called as annuity. Now let's go to the next question. We'll start with this question. The question helps us understand the annuity and the unequal cash flows better. This is an example of unequal cash flow. This problem is related to unequal cash flow. Let's learn to solve this. Mr. B invests rupees 500, rupees 1000, rupees 1500, rupees 2000 and rupees 2500 at the end of each year for 5 years. Calculate the value at the end. Please note the word at the end. At the end of 5 years, compounded annually, if the rate of interest is 5% per annum. The rate of interest is 5% per annum. So just let's write down the question. Simpler words. But what they're saying? They're saying at the end of year 1, you received 500. At the end of year 2, you received 1000. At the end of year 3, you received 1500. At the end of year 4, you receive 2000. At the end of year 5, you receive 2500. This is what has been told in the question. So for 5 years, you are receiving these amounts, and the amount is different. So it's a case of multiple cash flow. Now, it says at the end of each year for 5 years. That is at the end of first year, receive rupees 500. That means the number of period for which it is compounded, which it should be compounded for, is 4. Now, how is this 4? It is 4 because at the end of first year, we are going to invest 500 rupees. At the end of first year is nothing but the beginning of the second year or the beginning of the next year. For example, let me say that I have invested 500 rupees on 31st December 2021. So should I pay interest for the entire 2021? That's not possible because that has been done on the last date of the year. So 31st December 2021 is equivalent to 1st January 2022. Thus, I will not be providing interest for the year 2021. Okay, if it is anything is being done at the end of the year, that will not be considered. No interest will be given in such cases. It was that if the same question, if it was beginning of each year, then you should have taken here 5 years. Then 4 would have been wrong. But in this case, they clearly mentioned that it is at the end of each year. If it's at the end of each year, that means you'll get interest. For the first year, you won't get. For the second year, third year, fourth year and the fifth year. For these 4 years, you will be receiving interest. The next thing is 1000 is being invested at the end of second year. If it's being invested at the end of second year, that means you will get the benefit for the third year, fourth year, fifth year. That is, you're getting interest for the third year, fourth year, fifth year. You won't get the interest for the second year. Why are you not getting the interest for second year? Because you have invested the end of the second year. Had it been at the end of, had it been at the beginning of the first year or the beginning of the second year, you would have taken 5 here and have taken 4 here. But since it is at the end, you won't receive the benefit for that particular year, since the investment has been done at the end. Now similarly, for this it will be 2 years, for this is going to be 1, and for this it's going to be 0. Okay, this is the period for which is being compounded. So that is, this is nothing but n. This is nothing but your n. So what all we did calculation, this is the n. Now next, we need to use the table. Like previous class, how I showed you, there is a table for single value cash flows. Okay, single cash flow tables, future value interest factor table. We need to use that table and find the value. Now we know what is n. We know n is this. Okay, for 500 n is 4, for 1000 n is 3, for 1500 n is 2, for 2000 n is 1, 2500 n is 0. So in this case, how do you calculate? So we need to first see what is the rate of interest. Rate, that is your I, is nothing but 5%. Okay, so 5% for 4 years is what we need to find. For which we'll use this table. This table is the future value interest factor table for single cash flow. This table is for single cash flow. Okay, so 5% 4 years is nothing but 1.2155. 1.2155. Next, for 1000, 5% 3 years. 5% 3 years is 1.1576. 1.1576. Now for 2 years, 5%. Okay, interest rate is 5%, 2 years, 1.1025. 1.1025. 1.1025. 5% for 1 year. 5% for 1 year, 1.05. 1.05. This 2500 is at the end of 5th year. So that since it is at the end of 5th year, it will not get any benefit. Okay, there will be no interest paid for this. For 2500, it will be 1. Okay, for 2500, it will be 1. That means, let us understand this little more clearly. That means, these calculations, all these calculations are for rupee 1. Okay, rupee 1 in the year for which we are calculating. That is, all these values we are trying to find out at the end of 5th year. How much will 500 be at the end of 5th year? How much will 1000 be at the end of 5th year? How much will 1500 be at the end of 5th year? How much will 2000 be at the end of 5th year? How much 2500 will be at the end of 5th year? At the end of 2000, at the end of 5th year, 2500 is going to be 2500 itself. Okay, that is why I have been taking it as 1. 1 rupee is going to be 1 rupee only at the end of 5th year. But 1 rupee will not be 1 rupee at the end of 4th year. There it will be like, it will be 1.05. The value will be greater. 1 rupee will be 1.05. 1 rupee will be 1.1025. 1 rupee will be 1.1576. That means, these are the future values. These are the future value of 1 rupee. This is the future value of 1 rupee when your rate of interest is 5% and your n is this. Okay, when the n, let's just take this as an example. When your rate of interest is 5% and your n is 2 years. Okay, or your n is 2. That is, it's being compounded twice. Okay, if something is being compounded twice and the rate of interest is 5%, then the value of 1 rupee, then the future value of 1 rupee is going to be 1.1025. Similarly, if something is being compounded 3 times, if 1 rupee is being compounded 3 times, 1 rupee, if 1 rupee is being compounded 3 times at the rate of 5%, then it's going to be that 1 rupee's value will be 1.1576. So all these are future values of 1 rupee. All these are the future value of 1 rupee. Okay, that has been calculated with respect to these periods and with respect to the rate of interest. So we need to multiply this. We need to multiply this with this. What is this? Let me write it down. This is the future value interest factor. This is the future value interest factor which we found out using the table. This is the future value interest factor which we found out using the table. Now let's calculate it. 500 into 1.2155. 500 into 1.2155. 500 into 1.2155 is equal to 607.75. 607.75. 607.75. Okay, 607.75. Next, 1000 into 1.1576. That's nothing but 1157.6. Next, 1500 into 1.1025. 1500 into 1.1025. 1025 is equal to 1653.75. 1653.75. The next is 2000 into 1.05. 2000 into 1.05. 2000 into 1.05 is equal to 2100. 2100. This will be nothing but 2500. Now we need to do total of this. When you do total of this, you're going to get, let me do it, 2100 plus 2500 plus 1653.75, 1653.75 plus 1157.6, 1157.6 plus 607.75, 607.75 is equal to 8019.1. It's equal to 8019. So the answer for this is 8019. Answer for this is 8019.1 is the answer for this. Okay, this is the answer. This is the future value. So that means at the end of 5th year you will be receiving 8019 rupees. 0.1. Okay, now this is the next question is regarding future value of an annuity. For future value of an annuity, to make things simpler, there's a formula given directly. Before we go to the formula, let's see what it means. Annuity refers to the periodic inflows or the periodic outflows of equal and fixed amounts. Annuity refers to the periodic inflows or the periodic outflows of equal amount or fixed amount for equal and fixed amounts. Now this refers to future value of an annuity. Future value of an annuity, or is the accumulation at the end of n years or the amount at the end of n years. Okay, in case of annuity, which is equal to A. A is nothing but annuity. That is 1000 is being deposited every year. So 1000 would be A. So A is nothing but amount invested at the end of every year for n years. Amount invested at the end of every year. Amount invested at the end of every year for n years. Now what is this? 1 plus I. We know I is rate of interest and n is number of years. Okay, here formula is a little different. A into 1 plus I to the power n minus 1 whole divided by I. Okay, this entire thing whole divided by I, and this has to be multiplied with A. And again, as I told you, this is the value of 1 rupee. This is the value of 1 rupee. That is, value of 1 rupee, we have to find out what is the annuity of 1 rupee. 1 rupee is being deposited every year. Okay, if there's a cash inflow, cash outflow of rupee 1 every year, then what would be the value of that 1 rupee is what this is. That has to be multiplied with A. Then you'll get the future value of annuity. Okay, let's again understand this better by solving the problem. The problem says that Mr. C deposits rupees 2000 at the end of every year for 5 years. Mr. C is depositing 2000 at the end of every year for 5 years. Interest is compounded annually at the rate of 5%. Okay, so the rate is 5%, your N is 5 years, and C is 2000. You have to simply put this in the formula. Find the amount of money Mr. C would receive at the end of the 5th year. We have to find at the end of 5th year how much would C receive. Okay, now the future value of annuity is equal to, future value of annuity is equal to 2000 into the present value interest factor of annuity. Okay, for 5 years at the rate of 5%, the rate of interest of 5%. Okay, this is the easiest way to solve it. As per this, you are just putting it as a formula. This entire thing can be replaced by this. Entire thing can be replaced by this. So the future value interest factor of annuity at the rate of 5% for 5 years is what we need to find out. So here we are seeing something different. Before we were seeing future value interest factor of single cash flows. Okay, but this is in case of annuity. So in case of annuity, we have another table. There's another table, and that table's name is future value interest factor of annuity. Let's see that table. That is a different table. Please do not get confused with that table and the single cash flow table. Single cash flow table is only for single cash flows. Like for example, if I say that for 500, what is the future amount? For n years, the rate of I%, what is the value of it? If I'm just asking for a single value, yes, I'm telling you to find out what is future value for that particular amount, then use a single flow. For example, as we saw in this case, okay, we are considering though this is multiple cash flows, but we are taking this as single cash flow and individually we are calculating. That's why we use the future value interest factor table for single cash flows. But in this case, what is it? In this case, it is a little different. We are finding out for annuities. That's the difference. So this particular table can be used only when it is an annuity. Nowhere else it can be used. If it is the case of multiple cash flow, multiple cash flows wherein the amounts are unequal, you're supposed to use the single flow table. But if it is annuity only, then you have to use this table. Okay, let me use a table and show you. 5%, remember this, 5% for 5 years using the annuity table. So this is 5% for 5 years, or for 5 times it's being compounded. So it is 5.5256. 5.5256. 5.5256. When you multiply this, you're going to get 5.5256 into 5.5256 into 2000 will give me 11,051.2. 11,051.2. So my answer is this. This is my answer, and I found out this using the table. 5% for 5 years, 2000. So I used this particular table and I found out. Now there is another way of solving this. As you know, we have to use this formula. Using this formula is very easy because you have to just replace things. A is 2000. A is 2000. 1 plus 0.05. 1 plus 0. Okay, there's no place. I'll show it in another slide there. Okay, let me just delete all this. Again, that what are we doing? In method number 2, Method number 2, we are just replacing it in formula. Is equal to a into 1 plus I to the power n, 1 plus I to the power n whole divided by I minus 1. 1 plus I to the power n whole divided by I minus 1. Okay, please do not get confused. This entire thing has to be divided by 0.05. That means the entire thing has to be divided by I. So 1 plus I to the power n minus 1 whole divided by I into 2000 is the formula. When you do this, when you solve this, you'll get the same answer. You'll get 11,051. Okay, you can solve it this way or you can solve it this way. So basically this entire thing is being replaced by this. And why it has been replaced? Because solving this is easier. Here you need to use calculator. It will be really difficult while solving this portion. There is chance of errors. But you use the table, it is much more easier. Since you have to find just one value here and you have to multiply. There is only one calculation of multiplication. The rest of the value you get from the table. So that's why this one is easier. This one is a bit tougher and not that tough. But if your n is like, let's say some 20 years, then it's going to take you some time to solve. So in exams, if they give you the table, it's much better to use a table rather than wasting your time over this. It's another way of solving this. Okay, if you do not want to use the annuity table and you want to use the single flow table, then the method for that is what I'm showing now. See, 2000 has been invested for 5 years. At the end of like each year, this much amount is invested. At the end of first year, 2000. So the number of years for which it's compounded is 4. It has been compounded 3 times. This has been 2000. This 2000 has been compounded twice. This 2000 has been compounded once. This is not at all compounded. Okay, and we found all these values. These values has been found through the single flow table. Okay, it has been found with the use of table. Which table is it? The table is future value interest factor for single cash flows. Okay, that is the initial table that I showed you. This is the table. 5% for 4 years is this much, for 3 years this much, 2 years this much, 1 year this much. I have rounded off everything. That's why it is 3 decimal places that you can see. When you multiply 2000 with this, you get this. You multiply 2000 with this, you'll get this. So similarly, you have to multiply everything and you'll get the answer, which will be similar. There's little difference. Instead of 11,051, I've got 54. It has happened because of my approximation. If I had not approximated, I would have got the same value. There's nothing to worry about. But what we have to notice here is when we consider the single cash flow, though you can solve the question, though you'll get the same answer, but you need to find out the values 1, 2, 3, 4 times. So this is the problem. To reduce this problem, they have come up with this table of annuity, so that you do not do it for each cash flow separately. That's why in case of annuity, there is a separate table. Otherwise, if there is no separate table, you would have to calculate for each value separately. You have to calculate, which is again tiresome. Because here you need to calculate 1, 2, 3, 4 times. You have to refer the single cash flow table to solve this. Whereas in this particular technique, what we studied first, we solved it very easily. It was just one table that you had to refer, and it had to be referred only once. So annuity table, please use it for annuity. You can use a single flow table also to find the future value. But if you use a table, calculations will be more. To reduce the calculation and to make it just 1-step or 2-step calculation, it's better you go for the annuity table. This is a suggested method. Okay, please use the annuity table, then you'll get this. Thank you so much for watching. Please do like and subscribe. Thank you.